Hello everyone. I am back with my next video lecture, and in this video lecture we will discuss an important theorem, and this theorem is very important from the examination point of view. And the theorem is we have to prove analytically that when the central acceleration varies as some integral power of the distance, there are at most two apsidal distances. Okay, now what is given? Apsidal we have already discussed in the last lecture. Acceleration directly varies as some integral power of distance. Distance is r, integral power is n. This implies that acceleration is equal to mu rn, and we know force is equal to mass into acceleration. Mass is m and acceleration is mu rn, and mass is a constant quantity. Mass of the body never changes, and when this constant multiplied with this mu, this gives a new constant, and say this lambda rn, where lambda is equal to m, mu is a constant quantity, This implies that f is equal to lambda r raised to the power n. So we are given the force, and the law of the force is given, and we know that differential equation in polar form is given by, we know that differential equation in polar form is given by u plus d square u d theta square is equal to f by h square u square. That derivation we have already done. So, and we can substitute the value of f from equation 1. This will give lambda r raised to the power n h square u square, and you know r is 1 by u h square u square, because r is equal to 1 by u. This implies that u plus d square u d theta square is equal to lambda h square u raised to the power n plus 2. Here it is u square and this is u raised to the power n, so it is u n plus 2. This implies that h square u plus d square u d theta square is equal to lambda u raised to the power n plus 2. Next, we multiply both sides, multiplying both sides by 2 du d theta, we get h square 2 u du d theta plus 2 du d theta d square u d theta square is equal to lambda u n plus 2 du d theta. This implies that this can be written as d by d theta of u square. Okay, because its differentiation will be same. 2 will be here, u and u d theta. So this can be written something like that, and this can be written as d by d theta of, this is du d theta whole square. So, and the square brace is closed. This is 2 lambda u raised to the power n plus 2 du d theta. This implies that d by d theta can be written as h square is a constant quantity. Okay, this will be u square plus du d theta whole square is equal to 2 by lambda u raised to the power n plus 2 du d theta. Now integrating both sides with respect to theta. Integrating both sides with respect to theta, we get this will be d by d theta h square u square du d theta whole square d theta, and integration is with respect to theta. 2 lambda is a constant quantity, 1 by u raised to the power n plus 2 du d theta d theta. This d theta will vanish away, something like this is cancelling. So in the next step we are writing d h square u square plus du d theta whole square is equal to 2 lambda 1 by u n plus 2 du. Look here again, this d theta is like cancelling, but we will not cancel it physically. It is a kind of inverse operation. So du here will be, and this will be the total differentiation, and this is integration. So this will cancel out, and we should add a arbitrary constant c1. So this will be h square u square du d theta whole square square braces 2 lambda and u raised to the power minus n plus 2 plus 1 divide integration. We have done the integration plus 1 plus c1. This implies that h square u square plus du d theta whole square is equal to 2 lambda u minus n minus 1 minus n minus 1 plus c1. This implies that h square u square plus du d theta is equal to 2, this is u n plus 1, and this is n plus 1, minus is out, plus c1. Since we have to find apsidal distance, so we know that apsidal distance is distance between the center of force and the apse. Therefore at apse we know du d theta is equal to 0. This implies that h square u square, you may name it as equation number A. Using this in equation A, h square u square, this will be 0, is equal to minus 2 lambda n plus 1 u raised to the power n plus 1 plus c1. Now we know that this will be h square by r square is equal to minus 2 lambda n plus 1 r raised to the power n plus 1 plus c1, because u is equal to 1 by r or r is equal to 1 by u. This implies that h square is equal to minus 2 lambda divided by n plus 1 n plus 3 r raised to the power c1 r square. This further dividing throughout by 2 lambda, h square by 2 lambda minus is equal to r plus 3 divided by n plus 1 minus c1 by 2 lambda r square. Now multiplying both sides by n plus 1 minus h square 2 lambda n plus 1 r n plus 3 minus c1 r square 2 lambda n plus 1. This implies that now transposing this from left to right, we get r raised to the power n plus 3 minus c1 n plus 1 2 lambda r square plus h square 2 lambda n plus 1 equal to 0. Since r is a radius distance, so it is always positive. It is always positive. It is a radius distance. Now see, by Descartes rule, rule of sign. This equation, we look at that Descartes rule of sign states that the maximum number of positive root this an equation cannot exceed the change of sign in that particular equation. And you see that change of sign in this particular equation is one sign, because here is positive, so one change is from positive to negative, one change is from positive to negative. This is first change. Another change is from negative to positive, so this is change of sign. And there are two change of signs, one is this one, positive to negative, negative to positive. So this equation number say B cannot have more than two positive roots. That is by Descartes rule. Descartes rule states that an equation cannot exceed the number of positive roots by the number of variation in signs in that particular equation. So here are two variation signs, so this equation, so equation B can have at most two positive values of r, and r is representing the apsidal distance, because we have used the condition of the apse. Hence there are at most two apsidal distances. So this is the very important question from the examination point. You must do it, and it is very easy. So in this lecture we have studied that when center acceleration varies as some integral power of the distance, there are at most two apsidal distances. This is all I have from my lecture. If you have liked the lecture, please like, subscribe, share and comment. This is Dr. Rajesh saying a goodbye. Thank you very much. Thanks for watching the video.